Honestly, this is the video I can argue about endlessly because I see it in my work every week. Engineers, FDEs, product, customer success, everyone is getting loaded with requests to make everything agentic. And most of the time, once you understand the underlying cause and the pattern, it's easy enough to know when to say no and how to push back well. And here I want to help you do that with data and not just vibes like vibe coding.
Hi, I'm Ishwin Kaur. I build agentic AI systems in production, the kind that have to survive real users, not just look good in a demo. I've also sat on both sides of the interview table for agentic system design. Here it's going to be no hype, no gatekeeping, just the real building blocks with production experience and how to talk about them when it counts.
So the section one is get one thing clear. LLMs are non-deterministic by nature. LLMs are a genuine breakthrough. But notice that not everything around them is new. Vector databases already existed. The genuinely new thing is the LLM itself. And here's its defining property. It's probabilistic. Same input can give a different output. And that's not a defect, it's the whole point. They were built to produce natural language response, which should vary. And that has a direct consequence. If your system is built on an LLM, your system is non deterministic too. That's the nature, the behavior, the code, and it's not changing into deterministic no matter how the tooling evolves. And so this is where two conversations from my own work come in. The one of them was that I used a deterministic prompt, so it should behave. There is no such thing as deterministic prompt. You can reduce the variance, low temperature, structured output, few shot, but you cannot wordsmith the probability away. Another conversation was let's just use a small LLM. It will be deterministic classification. So if you have bounded categories and volume, that's a classifier's job, actually deterministic. So you are having sub 15 milliseconds, which is cheaper and trainable on the data that LLM already labeled. So small LLM is still an LLM. It still hallucinates. And I'm not saying you can't use the small LLM for simple tasks like classification, but hallucination can still exist and evaluation is needed for that system. Both these moments are the same lesson. Engineers have to debate and protect the AI versus non AI decision and educate the room that probabilistic by default is the breakthrough, not a bug that needs to be patched out. And then comes the section two, the blame reframe. Now, how to protect actually what you can do. So, yes, we can build systems around an LLM to behave in a certain way that we want. That does not mean it stops hallucinating or becomes deterministic. There is a fine line there. If you are blaming the LLM for being non deterministic on a task that needed determinism, you might be choosing the wrong tool. So the LLM isn't failing, the decision to use it was itself the failure. And the tasks actually don't need an LLM then. And then the section three, when not to use AI. Now, if something can be done by a deterministic workflow, plain code, a system trigger, a classifier, or even a small ML model running in sub 3 milliseconds, do it that way. Not because AI is bad, but because the non AI path wins on every axis that matters for businesses. And we are here to run business. So the latency, milliseconds, not seconds, used by LLM. Accuracy, exact, not usually right. Evaluation, deterministic evaluation is a big win, which is simpler and far cheaper than creating the probabilistic output. So build cost is also lower. Time to ship is faster, and the maintenance is easier. No prompt drift, no model migrations. That's the entire win for business. Now, when AI is actually the right call. So here's the LLM where it actually wins. Natural language is the point. Pattern recognition is a point. Understanding or generating language, handling ambiguity and the long tail, that is the point. Some non-determinism is acceptable, should be there. If a 5 to 10% hallucination or variation rate is survivable for the use case, then go for it. And be honest about silly. So harness engineering and good agentic design can squeeze that error rate down, maybe to approximately 2%. But can it eradicate it? I'm not that convinced yet. Because the core is itself probabilistic. And look at the signal the providers themselves say. Claude and Gemini label their own output as AI generated check for facts. So if the model's own makers won't vouch for determinism, why would you hand it deterministic autonomous actions? Also, here's a concrete failure that I care about: tool selection. With frontier models, I have watched them start adding a prefix to a tool name based on the context. So, calling a tool that doesn't even exist in reality. The fix isn't a better prompt, the fix is the system around that LLM. So, you have a force structured JSON output that defines an explicit error fields, validate before acting, and add evaluations on top of it. That's a real insight that you don't get determinism from the LLM or the prompt. You get it from the harness that you apply. So when the model returns an error as a sentence, you make it return JSON with an error field instead of having an output field having the error code. That's a determinism. That's harnessing, and that's what you put evaluations around and on. I want to talk about the production stories a bit. So there is a function named Leak. It is going to be a P1. A well-meaning prompt change told the agent to explain your capabilities to the user. It interpreted that as an instruction literally and started leaking the internal function names, like get case status to customers. And it's exposing internal API structure. That's a production issue. We don't catch it, a customer security team did, and it became a big P1. So the fix wasn't a better prompt, it was actually a separate evaluation layer, the injection check in our LLM as a judge in real time. The highest priority check that should actually block a response that is leaking the instructions out. The only one that never fails open. The lesson that I learned actually is that you cannot rely on prompt instructions alone for security. The LLM will find helpful ways to cross your boundaries. Then there is another one that a subtle hallucination was there. That judge once said that this is a grounded response when an actual human evaluation we did said ungrounded. The agent reported your case was updated on March 15, and March 15 was in context, correct? But for a different case. Now entity confusion is there. So what's the fix? The fix is to make the judge verify facts are attributed to the correct entity, not just present in the context. Here's another third one that I actually saw and observed is that fallbacks aren't free. When the primary model rate limits or times out, you fall back. But the same prompt doesn't behave the same across models. One accepts an implicit, be concise, another needs like 3 sentences or fewer to be explicitly mentioned. Every fallback model needs its own prompt instruction and prompt version. And that is where I came up with prompt as a first-class citizen. And we can discuss more on this, and I can create a separate video of how to have that for enterprise scale. So all these three reinforced in the section 4 is that determinism and safety comes from the system around the model and not the model itself. What I want to go towards is how to push back to your leaders, to your customers. And this is the part people ask me most. When you're funded with a task that says like, make this agentic, and you think it's actually wrong, Don't argue with them with saying that LLMs hallucinate. I think everyone's have heard it and everyone knows it, and it changes nothing. Instead, do this. Step one is write the layer options top that you might have for your production system. Lay out the ways the problem can be solved at different layers. So there is one as LLM layer, there is one as non-LLM, deterministic code or workflow. Hybrid can be used NLM plus non-NLM companionship, or a layer somewhere else in memory or somewhere that you can actually use in this entire system of your production. And this is the most important point why engineers are not going to be obsolete. Write it down. Engineers who can sit with non-determinism, analyze systems, and provide solutions to problems are actually needed. And that is where system design and agentic system design has become a signal. And then the step two is score each of the options that you have on the axis that leadership or business actually cares about. Like having a latency as an axis, having an accuracy, evaluation, testing, maintenance, and fallbacks or retries needed. And in the result, you can have like an axis for NLM layer that you actually evaluated on. When you had no LLM layer, determinist, what were the values for each of these axes and any other system layer? That is the data that you are gathering to convince the room to help understand what is the best approach towards solving this business problem. And this is what made leadership get it for me. It shows concretely why, let's say, a classifier makes sense and why a small LLM will still hallucinate. It converts your instincts into a decision that they can own and make also with the data that you provided to them. Now, step three, if they still don't agree, run the bake-off. Build a quick Rocker test of the AI and the non-AI approach that you have and run each n times. If the LLM isn't suited to the task, it will fail something around like 3 or 4 times out of 10 runs. And that might not be simply acceptable for a deterministic business critical task. And data ends that debate there itself. So your grounding in the basics is what lets you drive this with data and the content instead of a one-time line about LLMs are hallucinating. And that's how you earn a senior or lead engineer in the room. Now, before I go, I want to mention that pushing back is not being anti-AI. It's the opposite. It's being the engineer who puts AI exactly where it wins and keeps it away from where it will quietly cost you a P0 or a P1. And the breakthrough is that LLMs are probabilistic. Let's respect that. Build the harness where you need language and use deterministic tools where you need guarantees. And bring data when someone says, just make it agentic. And that judgment runs through everything I have built with Core that we'll discuss in depth later for our agentic system design. I'm excited to learn with you.
If you take one thing from this, I hope it makes the next interview or the next thing you build a little less intimidating. Tell me in the comment what is still hard or what you want covered next. That's where I get my best ideas. And like if it helped, subscribe for the rest of the series and I'll see you in the next one.